Hello, Tom from Every Step Calculus, everystepphysics.com. I thought I'd add my picture to make it a little more personalized here when you're looking at this worthless stuff that doesn't solve anything. Of course, that's calculus, and I'll show you why on this problem. This is the evaluated integral using an u-substitution, so let me show you how this works, okay? Index 8. To get to my main menu, I'm already at u-substitution to save time. You'll scroll down to it. And of course your trick is when you buy my program that you're going to hold this second key down and then use this cloverleaf cursor up or down to go screen by screen. You can go really fast because there's 136 items in this menu, all dealing with all your calculus problems in your tests, homework or whatever. And we press enter, and we're going to enter the function here, this function, okay? Press alpha first, alpha x cubed times second, and the x here is the square root sign for the titanium, x squared plus 4. And I always give you a chance to change in case you made a mistake. Now you could find the integral of this even with u-substitution. You could do that, right? I don't think so. Okay, that's what you deal with. And of course it looks simple enough. You say, oh my gosh, that looks pretty cool. Maybe I can do this. So we're going to rewrite it. It's one of the tricks. X squared here in front, and then x dx over here. With u-substitution, whatever in this here has to be matched to here. For instance, the derivative of x squared is 2x, right? Well, you'd have to do something with the 2 to get down to x dx, but I'll show you how that works here, okay? So we rewrite it like that. You write that on your paper. Of course, this is a whole page of calculations, so don't think this is easy. So we make u equal to the square root of x squared plus 4, okay? Now we make u squared equals x. We take this, square it to get rid of the radical sign here. X squared plus 4. Bring the 4 on this side and isolate the x squared. Then we have x squared equals u squared minus 4, okay? I just did that to clean it up a little bit. It's already here, but we switched it around to make it easier for the next calculations. We differentiate both sides, so d dx of x squared equals d du of u squared minus 4. That turns out to be 2x dx equals 2u du. And of course the 2's come out because they're on both sides of the equation. And we have x dx equals u du. Now here's the x dx, which is exactly equal to what we rewrote the problem to before. You remember that? Okay. That's the secret to. That's the reason you got to know your derivatives pretty good in calculus, and integrals. Simple, to do them quick. So then we switch u squared minus 4 into the problem. Turns out to be this. And then we multiply u times u, which get u squared du, integral of u to the 4 minus this right here, integral of u to the 4 du. Now we're going to, when you integrate, you can always integrate when there's a plus or minus sign between them. You can't when there's a time sign. So this is now designed and made to happen like that. Of course, these are all set up pathetic problems, by professors. Just puzzles like Sudoku or crossword puzzles for you to figure out, make you miserable for your homework. So we're going to integrate each one of these separately, which we do with respect to u. Okay, turns out to be u to the 5 divided by 5 minus 4 u cubed divided by 3, and of course plus c. Okay. Next screen, we're going to factor, bring out the u cubed out of it, and we get this right here. Okay. Now we have to find the common denominator between 5 and 3, okay, which is 15. We do those calculations. We got 3/15 minus 20/15. Okay, we factor out the 1/15, and we get u squared minus 20. Okay. We back substitute, bring all that back into the problem. 1 over 15 times, bring it back in. U squared, remember, was equal to this. So that's cubed times 3 times u squared, etc. And this is all complicated even when I look at it. I mean, but it's all accurate. And then we square a square root. So that turns out that we get rid of this square root here. Where is it? This square root here. When you square a square, you get what's inside of it. So we have that. And we keep going. We got 12 plus 3x squared minus 20. Well, 12 minus 20 is minus 8 right here, right? Etc. And you got 3 halves. Of course, when you got the square root cubed, it turns out to be, when you get rid of the radical sign, what's inside that the parentheses of a square root, you get 3 halves. Okay. Of course, you know how to do that from algebra, right? That's so easy for all of us. And you'd be able to get all this exactly correct, wouldn't you? I don't think so. Okay. And then I've designed the program. I'll bet you I couldn't do it in a test either, by memory, all this stuff. I probably could, but I mean, it would take me a long time. I wouldn't be able to finish any other problems in the test. So we keep working it, and then we get the answer here, which is this x squared plus 4 to the 3 halves times 3x squared minus 8, all of it divided by 15. And of course plus c, that's pathetic too. This is a indefinite integral, of course. A definite integral has a range. And this is the area, supposedly, under the, if you put a value to x and come up with a number, that will be the area under that under this function here when you graph it, okay? And of course you don't know what it's squares, area is squares, and but you don't know what is square feet, square yards, what is it? Well, that depends on the x-axis of the graph. These are all graphable. Everything in calculus graphs, okay? And integrals must be you have to be a really smooth curve, nice smooth curve with for it to find the area under, and it does. But notice then you have to come up with a plus c. You have to come up with a constant, because there are 10 million solutions to this problem unless you know the c. See, so that's my bitch about calculus, is that whoever designed this function, for instance, like they'll make it like this is a field of a electron going through a couple of protons or whatever they say, they dream up, and somebody has to design these programs. Well, calculus can only work with functions like this. If it doesn't have a function, it can't work. Somebody has to design the function. You'll notice how there's no class for designing functions. Have you ever noticed that? It's because it's too hard. You can't do it. So calculus solves nothing. Certainly for us it doesn't. It's a waste of time for us, but we have to pass these classes and get out of there and get onto our degree in our life. So that's where these programs come in handy, and they're only $40. You get 460 of them for $40. Think about that, how cheap that is per program, and how much time I've put in to program that stuff. And well worth it. Throw your calculus book away, throw your study material away, keep your calculator. It's for the rest of your life you can do calculus, because you have it, your programs in this, if you buy calculus 1, 2, 3. And it's all in your titanium calculator, And you'll know somebody in the future that takes calculus, believe me. Grandkids or partners or somebody is going to take business calculus, all that garbage that they dream up. So anyways, you have a good one. Good luck in your classes. All right? See you later.